I have been curious about Chinese frames for quite a while. Lately, the quality of frames coming out of China has been really high, so I figured for my next build, I might as well try a Chinese frame. This one is a Twitter C6. They advertise it as a road bike. This one is made out of aluminum, so it's an aluminum frame and it came with a carbon fork. I really wanted to go with a carbon frame, but since the United States has implemented tariffs, the price of those frames has gone way up. You're looking at about $1,000 for a new Chinese carbon frame. That's just too much money to risk on something that might not work out. The aluminum frame, this one cost me $365, I think, and that included shipping, so that included the cost of putting it on a boat and sending it over to the United States. That's not too bad, even if it is just an aluminum frame. So in today's video, I want to take this cheap Chinese frame, I want to build it up into a complete bike. I want to see what it takes, what hurdles we hit, and how we overcome those. Everything from frame to first ride. If you're interested in that, let's get started. Let's start by taking a look at the frame. I've looked the whole thing over. I want to show you guys some of the things I think are really good about it, and also some of the things I think are bad about it. The first thing I noticed about this frame when I pulled it out of the box is that the finish on the frame, the paintwork, is really quite nice. It's a pearlescent white. That pearlescent has been really evenly applied. The clear coat is nice and smooth. There's not a lot of orange peel on the frame. The finish on it looks like a high-end finish. The second thing I noticed is that it's a really nice design. So I did a little bit of research, and to me, to my eyes, it looks like this is a copy of a Tarmac SL8. I think that's what they were going for, or maybe their inspiration. But regardless, I think the design of the bike or of the frame is really quite nice. One of the things I really like about this frame is it's designed around modern bike standards. It uses flat mount hydraulic calipers, through axles with 142mm rear spacing. It's got a carbon fork and a 52-52 headset. It also has a couple of things that modern bikes have that I don't like. It's got a D-shaped seat post, and I did some measuring and I can't find that seat post anywhere. So if you want to replace the seat post, you're out of luck. The other is that it's got internally routed cables that run through the headset. Being that this is a hydraulic brake bike, or it will be a hydraulic brake bike, having to deal with hydraulic brake lines every time I need to service the headset, I think that's going to be a real pain. So I like that this frame is designed around modern bike specs. What I don't like is that it uses internal cables that run through the headset and the D-shaped seat post. One of the things I really don't like about this frame is the front derailleur braze-on mount. It's welded in place, and they took a lot of time welding it and smoothing out the welds to make the backside look good. And then the front side, they did 2 tack welds and they left it wide open. Just this big gap, they didn't weld that in. When the derailleur is installed, you can't even see this part. So all you're left looking at is this big ugly gap here. What I don't like about it is it just looks like somebody forgot to finish welding the frame. One of the things that concerns me about this is the quality of the welds. So you're looking inside the head tube. Take a look at that weld right there. It's not smooth all the way around. It looks like tack welds, like they tacked it together. I'm hoping that the welds on the outside were better, but my concern is that the welding here, the quality of those welds is pretty low. So if the welds on the outside were also lower quality, and then they took a grinder to those, I'm worried that these welds may crack. So I suppose time will tell. Another thing I don't like about this frame is how the seat tube looks. So this is a cast aluminum piece that has been welded to the tubing here and right here. And what they did is they welded it in place and then they ground down those welds. But when you look at it, there's these bulges. So there's a bulge here and there's a bulge here. And those really stand out when you start looking. So they're not consistent side to side, and they're even a little bit wavy. So whoever ground them, maybe they were quick, they didn't spend a lot of time at it. There's also a couple little pinholes right here in the welds. So the welds have some porosity to them, and when they ground it down, they expose that. This is the front derailleur cable stop. So they installed this by tack welding it top and bottom. Apparently they thought that was good enough and they called it done. But there are these big gaps between it and the bottom bracket shell. To my eyes, it looks as unfinished as the front derailleur bracket did. This is the rear brake mount. Where they attached it to the rear stay, they just left this big wide open hole here. I don't know if that was a design choice for weight reduction or what, but all that thing is going to do is let water run right in and right down into the bottom bracket. We're going to have to find a way to fill that in. None of the bad things I found about this frame are really deal breakers. I think we can solve all the problems we encounter. Before I do anything to this frame, I want to see what it weighs. So we're zeroed out and we're reading in kilograms. So it looks like it's weighing in at 1.58 kilograms or 1,580 grams. That is equal to 3.48 pounds. So the fork weighs 0.43 kilograms or 430 grams or 0.95 pounds. So I want to start first, I want to get the fork ready and I want to get the fork installed. These are the brake mounts on my new carbon fork. You can see when the fork was made, not a lot of care went into keeping these flat. If I leave these like this and I install the caliper, it's going to be impossible to get it lined up correctly to the rotor. So I got to fix this. To make sure I got the alignment exactly right, I made a jig. So this is effectively a pair of V-blocks that bolt together. The way I'm going to hold this in the mill is I am going to put the through axle into this and clamp it in place. That then will ensure that the through axle is square to this face. I'll take this and I'll mount it in the vise, and then when it's in the vise is already properly aligned to the mill. So I will know then that this through axle is correctly aligned to the mill. I used an angle finder to make sure that the fork is squarely mounted to the vise. I'm using a brand new 5/8 inch end mill. I wanted an end mill that was good and sharp to make sure I got a good clean cut and a good clean surface. I started the mill, I set it to 1250 RPM. I made 3 passes. Each pass I removed 0.1 millimeters or roughly 4/1000ths of an inch. I wanted these passes to be light. I wanted to be careful and take my time so that I didn't screw something up and remove too much material. I nailed it. I've got the caliper put back on. Note the consistent gap between the pad and the rotor, top to bottom and on both sides. This caliper couldn't be better aligned to this rotor. Here's a look at most of the parts that are going to go on this bike. We'll talk about each one in greater detail as I put them on, but from a high level perspective, we've got an Ultegra Di2 drivetrain. We've got a Chinese carbon aero drop bar and a Chinese carbon 3D printed saddle. I think this thing's pretty cool. We've got Ultegra brakes, a ceramic bearing bottom bracket, and an internal cable headset. They didn't include a lot of stuff with this frame. What I did get is the seat post and clamp, the derailleur hanger, and the pair of through axles. So I didn't get a headset. I didn't get any of the frame finishing parts like cable grommets. So we'll have to come up with all of that on our own. I'm assuming a little bit of risk here, and I'm going to run a set of carbon drop bars. These aren't a name brand set of bars though. These are the cheap ones you can get online for about $100. These are branded by RSL. I did buy their matching headset top cap so that it flows seamlessly into the head tube. I didn't get any info with this frame, and finding information online is difficult. There's not a lot out there on this bike. Most manufacturers recommend a max of 40 to 50 millimeters from the top of the head tube to the bottom of the stem. This measures in at 41 millimeters. I think that's where I'm going to run it. So I want to cut the steerer here down. The best way to cut down a carbon steerer is to use a wet saw or a tile saw. These always produce good professional results, and they do it without any damage to the steerer. I mentioned earlier the frame didn't come with a headset, so I'm kind of on my own when it comes to putting one together. The fork is a tapered fork. It tapers down to 1.5 inches, so I got 1.5 inch split race. I like split races for carbon forks because they're easy to install. I then needed 1.5 inch bearing to fit into the head tube. Because I'm running wires and hoses through the headset, I wanted the best bearings I could get. These are Enduro bearings, they're stainless steel. They cost $35 a piece and I needed 2. The top bearing is exactly the same as the bottom. It's another 1.5 inches by 45. This is the top cap. It came with the headset that is designed to work with those handlebars. If you look at the underside of it, it's just completely smooth. So we don't have any surface to provide preload to this bearing when tightened down. So I came up with this design. I designed this in SolidWorks and I 3D printed it. It's made out of PETG plastic. The way this works is this fits in the bearing, and then when the preload cap is tightened down, it pushes into the bearing like so, and it grips the steerer on the fork. So when the top cap is tightened down, it compresses the steerer and we've got our preload. I wanted an aero cap to go with it. An aluminum cap and spacer just looked out of place. I decided to make one instead of 3D printing one. I covered the stem with masking tape to protect it. Then I installed a bolt down through the expansion plug just to keep epoxy out of the threads. I'm going to use some JB Weld steel stick. This is a 2-part epoxy putty that you knead together. It sets up in about 5 minutes, gets rock hard. I squished on the epoxy and I shaped it to the best I could to fit the stem. I let it cure for about 5 minutes, then I removed the bars and I popped it out. I wasn't really happy with the shape of it after I pulled it off, so I used some 220 grit sandpaper to sand it to shape. The hardest part here was actually getting the thing symmetric. After I was done making it, there were some defects in the epoxy putty and it didn't look very nice, so I filled those in with some filler primer. I then smoothed that out with some 400 grit sandpaper. I finished with a coat of Krylon textured black. This is my favorite spray paint for bike parts. It looks really close to a factory finish. It wouldn't be a bike video if I didn't weigh it. The cap itself weighs in at 13 grams. With the bolt, it's 17 grams. I set the preload on the bars using the aluminum cap and spacer, and then I bolted the new aero cap in place. This aero cap is probably strong enough for preload, but just in case, I'm only using it as a cover. So I'm using a set of Shimano R785 levers. These are going to connect to the handlebar, and we're going to run a cable from them in through the handlebar, and then inside the stem, I'm going to sit this Wi-Fi module. From there, we're going to run a wire through the rest of the handlebar down, and that's going to connect to the handlebar junction. So this will fit right in the end of the handlebar, typically where the plug would go. This has got a mode switch, and it's also got the charge port. So the charge port lets me charge it, but it also is how I send configuration from my computer. So that will sit in the end of the bar. Then from there, we'll run another wire through the handlebar, in and down through the head tube into the down tube. It'll then run through the down tube and connect to a 4-port junction. From this junction, we're going to run 3 wires. One wire is going to run around the bottom bracket up through the seat tube, and that's going to connect to a battery that is mounted inside the seat post. The second wire is going to run from the junction around the bottom bracket up out this hole, and that one is going to connect to the front derailleur. And the third wire will run from that junction down around the bottom bracket into the chainstay, through the chainstay, out through a hole in the end, and that one will connect to the rear derailleur. Here's what I'm using to fish wires through the frame. This is just an old brake cable with a couple bends on the end. Those bends are there because as I push it through the frame, I'm going to rotate it. And by having the bends, it gives me a much better chance that that will find the hole and push through. So for the front derailleur, I'm actually going to come in through the hole up here and try and fish it out through the bottom bracket. To attach the Di2 wire to the fish cable, I just overlap it and then I use a piece of electrical tape. I install it lengthwise though instead of widthwise. That gives me a lot more surface area to work with, and it kind of acts as a spring, reducing the risk that this cable will pull out as we're pulling the wire through. On this frame, the rear derailleur wire will route through a hole at the end of the dropout, down through this contour and into a hole at the end of the stay. So it'll go through like that. This is just a temporary connection so I can test the system. The rear brake hose is supposed to run through the down tube, out a little hole at the bottom, and then back to the caliper. This exit hole, I don't know what they were doing here, but it does not look finished. So I wanted to clean that up. I masked it off to protect the paint, and then I just used a small file to clean up the edges. It looks so much better now than it did when I got it. So I screwed up, and this is a pretty big screw up. I had run several wires down around the bottom bracket. I wanted to make sure I had enough clearance. So I took a brand new external bottom bracket and I threaded it in on the drive side. The bottom bracket did get a little tight right at the very end, but this is not uncommon. I used a wrench and I snugged it up. It snugged up just fine. When I went to remove the bottom bracket, it backed out about a quarter turn and then it got really stiff. So I thought, oh no, and I threaded it back in. It went back in just fine. Then when I tried to back it out, it made it about 1/8 of a turn and then it seized up and it wouldn't come out and it wouldn't go in. What I should have done is taken and cut the shell of the bottom bracket apart with a hacksaw and then drifted it out with a punch and saved those threads. That's not what I did. What I did is I took my impact and I put my bottom bracket wrench in it and I ran the bottom bracket in and out several times until it came out. I was hoping I'd have a little bit of thread damage, but I wasn't so lucky. I had a lot of thread damage. So when it came out, it was missing all the threads from the last 1/4 inch. The frame was in worse shape. All of the bottom bracket threads were gone. They weren't just messed up, they were completely gone. So in the matter of about 30 seconds, I had completely ruined this frame. So I started thinking about ways I could fix it. And I came up with a number of ways that I could fix the damaged threads. None of which actually would be feasible. They wouldn't work, but I came up with a number of ways. And then I came up with the way I actually did fix it. The first thing I tried, or I wanted to try, was to chase the threads and see if a new bottom bracket would engage. Looking at this bottom bracket that came out though, the threads are completely wiped out. So a BSA English threaded tap isn't going to do anything but waste money. So then I thought, well, I do have a mill, maybe I could bore that bottom bracket out and I could thread it for Italian threads. So I would bore it out and I would tap it with an Italian tap for the larger bottom bracket. Unfortunately, I went looking for an Italian threaded bottom bracket tool, and you can't buy the Italian threaded tool. You have to buy the tool with the English threaded taps and then buy separate Italian taps. When that's all said and done, that runs about 550 bucks, and that's if you can find the Italian taps. They were sold out everywhere I looked. So $550 on a gamble that this might work. I mean, it would probably work, but $550 well exceeds the cost of that frame. I could buy a frame and a half for that price. And I don't think I'd ever have another use for an Italian bottom bracket threading tool. So taps and retapping that bottom bracket or that shell are they're not feasible. So then I thought, well, maybe I'll get one of these thread together bottom brackets. So the next size up from an English threaded bottom bracket is the BB90 standard. Unfortunately, the BB90, the 90 part in that name means that needs a shell width of 90 millimeters. The shell width on that bike is only 68, so that's 22 millimeters difference. I thought, well, maybe I can make it work and use spacers, but what killed that idea is the crank. So the crank axle on Shimano cranks. You can see where the bearings ride. This is 90 millimeters apart. So that you can install this without it being an absolute bear, Shimano actually reduces diameter right here. The distance where that necks down is greater than 68. So even if I got this down to 68 and I use spacers, these bearings would end up riding on this narrower section and the crank would wobble. So the BB90 is out. So then I thought, well, we'll go for the next size up. So the next size up is the BB86. That's got a 41 millimeter diameter shell. So it's designed to fit inside a 41 millimeter hole. The bottom bracket shell on that frame is only 44. So if I took that bottom bracket shell and I bored it out so this would fit, the wall thickness on that shell would only be 1.5 millimeters. Way too thin for a bottom bracket shell. So that's out as well. So that's all the options I had at hand. So then I get to thinking, well, what if I would sleeve it? To remove those damaged threads and open up the bottom bracket so that a sleeve will fit inside, I'm going to use the boring head in my milling machine. I clamped the frame to the table and I took measurements on the inside of the bottom bracket where it hadn't been threaded. I aligned it so that it was perfectly square to the table. I then adjusted my boring head out to a diameter slightly larger than the damaged threads. I really took my time boring out the bottom bracket shell. I did it in multiple passes so I didn't remove too much material. Now that I've got the bottom bracket bored out for a new sleeve, I need to make the sleeve. I have this old Trek frame that has a cracked head tube. I was going to try and repair it, but I need it for this more. So I used my Sawzall and I cut out its bottom bracket shell. That left a really rough surface, so I mounted it in my drill press and I used a 1/2-inch end mill to remove as much excess material as I could. Because I'm going to mount this in the lathe, I need to get it as round as I can, so I used my belt sander to remove any remaining material, get it as round as I could get it. I then mounted it in the lathe and I turned down until I had a good consistent finish. To make sure it was as centered as possible, I used a dial indicator to measure the runout. This dial indicator reads in microns. The best I could do was about a 40 micron swing, which I think is pretty good. So when I was happy with how well centered the shell was in the lathe, I turned it down to final dimension. I bored the frame out to 1.4934 inches. To get that 1.5 thousandths interference fit I was looking for, I turned the sleeve down to a final diameter of 1.4950 inches. Getting this sleeve perfectly aligned into the frame when I press it in is critical. I didn't want to just rely on me getting it straight and square before I pressed it in. So I actually sized the two sides of the bottom bracket shell slightly different. I sized the right hand 1/1000th of an inch smaller. So basically I've got a step design. When I press it in, both sides still have a 1.5 thousandths interference fit. But because the drive side is slightly smaller, I can insert it in the frame halfway, and then when I press it in, I'll get my interference fit, but I will also know that it's properly aligned. I inserted the sleeve into the frame, and I used my hydraulic press to press it in place. To make sure this thing never comes out, I used a little bit of Loctite 648, so this is a retaining compound. I applied some to both sides of the bottom bracket so that when they press together, it'll lock it in place. The press went really well. The fit was perfect. It pressed right in, but just with the right amount of force. So here's a look at how the sleeve turned out. I cleaned it up after I installed it with a Scotch-Brite pad just to make sure that it was clean, and then I threaded in a bottom bracket to make sure it fit. I had to strip the bike back down to fix that bottom bracket shell, so all of those cables you saw me pull through the frame, they're not in here anymore. I'm going to pull those back in, get it back to the point where it was before I screwed up the bottom bracket shell. I needed to add a little more clearance inside this bottom bracket sleeve that I put in, just to give the wires somewhere to route through. There was room in there, but it wasn't quite enough, and the edges were pretty sharp. So I used the Dremel and I just cleaned those up. I opened up the holes a little bit so the wires would fit through, and I removed the sharp edges so that I won't have to worry so much about the wires chafing or getting damaged. After that fiasco with the bottom bracket, after I spent 3 days repairing that, I decided I'm not going to waste my time on another Chinese bottom bracket. So this time I went with a Shimano BRMT501. I like this one because it's got larger cups and larger bearings, but those larger cups sort of squish, I guess, sandwich the bottom bracket. So it should just help with the strength, especially with my repair sleeve. Instead of using the insert that Shimano included, I made my own, and I did it in a 2-part design. So I've got one part that fits into one bottom bracket, and then I've got the other that fits into the other side. And when this is installed, the two fit together, and they should fit together tightly. There we go. So what I can do is I can put the wires in, I can install one side, and then I can install the other. I'll still get the benefit of having this in place, but I won't have to worry about it pinching the wires. These shifters I'm using, they've only got one E-tube port each. So I can't bring 2 wires in and connect them up. So I've got to use one of these Y-splitter cables. The one I have isn't long enough. So what I did is I cut it and I extended it and then I soldered it. So it's got to go in right here, all the way through and come out here and then come out the bottom. I think the best way is to insert the pull cable into this one and try and snake it through and out the end of the bar. No. So it's pushing in, it's turning, and it's getting wedged up here. Yeah, I can see it in there. What if I go the other way? It's doing the same thing. It's hitting that stupid stem. Darn it. So I've got to be able to put this in, hold it in place, run all the hoses and wires, then connect the handlebars. I'm not sure how we're going to do this. So I figured it out. Instead of putting everything on the frame and then trying to fit the bars, you do it the other way. You completely assemble the bars and then you put them on the frame. I got the hydraulic hose, I got the Di2 all routed through. I've left a bunch of extra hydraulic hose here so that I can run it through the frame. I think it's going to be in my best interest to put the levers on and connect up the hydraulic hose, connect up the Di2, that way I can check and make sure it works. But do all that, get the handlebars fully assembled before I try to put them on the bike. I'm not entirely sure where I want these positioned. It's going to be kind of a trial and error. And it's important because the length of the hoses matters for this. So we're going to kind of eyeball it. And we'll see if we can get this to where it's close. I think I want the top of the lever. I usually like to set it so the front of the brake is straight on, or up and down, perpendicular to the ground. Looking at where everything is lining up, I think we're going to be somewhere maybe right there. Ah! So now I've got to put the bars on the bike. I'm sure there's a sequence here, but I don't know it. I think probably the best way is to run the hydraulic hose through the frame and then use that kind of to carry the weight of the bars while I put together the fork. I finally got the front end put together. It took me a couple of hours to do it. I had to do it twice. I got everything together and then I realized I'd forgotten to install the headset top cap. Forgot to route it through the top cap. So I had to pull everything back apart and redo it. It was a real exercise in patience. I didn't have a lot of fun putting this together. But now that it's together, it works really well. Nothing's rubbing, the handlebars move freely. And honestly, I think it looks really nice. So now that the front end is together, let's finish the bike. After all the grief that the internal cable routing gave me, the rest of the bike went together without any issue. But before I show you guys what I built, I do want to weigh it. And I will zoom you in so you can get a better look at that scale. I just want you to see that there's no shenanigans here. So it looks like the final weight of the bike is 19.12 pounds or 8.97 kilograms. That's quite a bit under 20 pounds. I'm really happy with that. Now that we know what it weighs, let's take it outside, take a look at what I built. Before we talk about how this bike rides, I want to talk about how much it cost. I think most of us would buy a Chinese frame like this to save some money. So the bike, as you see it here, aluminum frame, carbon wheels, carbon bars, carbon saddle, and electronic drivetrain. This cost me $2,133 to put together. I've included a breakdown on the screen of all the parts and what I spent. Of that, the majority was the frame, the wheels, and the drivetrain. The frame and the wheels together were nearly $800, and the Di2 setup, that was almost $900. Di2, even the older 11-speed, is still really popular, so finding those parts, even if they're used, they still command quite a price. Let's take a moment to talk about sizing of these Chinese frames. This frame is a size medium or a 48. Chinese frames are not spec'd based on their top tube length. Instead, they use the seat tube length. So this frame has got a 48 centimeter seat tube. It's actually got a 55 centimeter top tube, so this frame would be sized to 55. I'm 5'11", and this 55 frame with a 100 millimeter stem fits me perfectly. So if you're gonna get one of these, you're gonna order it from China and wait a while, and you definitely don't wanna return it, take a look at the size chart that's in the ad. Disregard the number on the frame and instead look at the top tube measurement. That's going to effectively give you the size of the frame. Now that I've put some miles on this bike, there's a couple things I want to talk about. The first is how it rides. And I'll be straight with you guys. I've only put 3 rides or about 70 miles on the bike, so keep that in mind. I don't have much to say about how it rides other than it rides like a $2,100 road bike should ride. It's fast, it's agile, and it's really confident in the corners. That's pretty much all I can say. You get what you pay for in the way this bike rides. The other thing I want to talk about is, would I do this again? So when I ran these wires through the headset, I was so frustrated. In that video footage, I probably said a dozen times that I was never doing this again. I tell you, I will never again, never, ever, ever put together a bike with internal cable routing. Now that being said, when I stripped out that bottom bracket, I was so convinced that this frame was done for, that it was trash. I didn't think it was repairable. So I ordered a replacement frame for it, also from China. The replacement is a carbon version of this frame. So this is the Twitter C6, that one's the Twitter V1. It's on a boat somewhere in the Pacific. I don't know where and I don't know when I get it, but it also uses the same cable routing. So when it gets here, I'm gonna do it again. Now, whether or not you should do it, that's kind of up to you. I will say that this frame isn't anything special. For $370, I got a fair deal. It wasn't a good deal, it wasn't a bad deal, it was a fair deal. This is a $370 frame that's worth about $370. You can probably get a very similar frame, maybe used on eBay, an aluminum frame with all the technology for about the same price. So if I were you, I would not waste my time getting a frame from China, but I would get these other parts. I'm really impressed with the handlebars, I'm really impressed with the seat, and I'm really impressed with the wheels. The handlebars, these are carbon. They were 120 bucks. They're nearly identical in appearance to my Bontrager Aeolus bars, and those were 600. I ran an endoscope through these bars. I don't see anything on the inside that's concerning. They seem to be just as well made as the Bontragers. They are stiff, but they're also quite comfortable. They nailed the geometry of the drops. So I'm really impressed with these bars. I'm also really impressed with this saddle. It's 3D printed and it sits atop a carbon base. The whole saddle only weighs 115 grams and I spent less than $100 on it. The best thing I can say about it is when I'm riding, I don't even notice it's there. And then these wheels, these are Star in-air wheels. I think that in-air is kind of a dumb branding because they put it on the side and they put it right by the Presta valve. So when you look at it, it looks like it's saying this is where you put the air in, and well, yeah, of course that's where it is. But no, it's just branding. These wheels were on my Diamondback Podium. I pulled them off and I replaced them with a nicer set of Vision wheels. And I was a little frustrated when I got those Vision wheels because when I pulled them out of the package, these rims and those rims have the exact same manufacturing barcode, date, sticker on them. And it's not just stuck on, it was put on before they did the epoxy work. So it was done when they built the rims. So that means that the Vision rims and these Star rims are made in the same factory by the same people and given different paint jobs. So $1,300 for the Vision wheels, $370 for these. That's an incredible value. So I suppose that's a long way of saying, if you're going to do something like this, don't waste your time on the Chinese frame unless you can get one that you think is nicer than anything else you can get locally. But take a chance on the bars, the seat, the wheels, because this is where the value is. If you're considering installing Chinese carbon parts on your bike, there's some things to keep in mind. Chinese manufacturers will save money when they make these parts in several ways. They will typically skip finishing steps. They may or may not do quality control, and they infrequently offer any sort of assurance on their product. For finish work, most Chinese carbon parts I get, like handlebars, seat posts, and forks, require some sort of finishing work before I can use them. As an example, on these bars, the ports where the wires and the cables route into the handlebars, those were not the same size, they weren't the same shape, they weren't in the same spot, and they were really sharp. So I had to spend about an hour with a file, cleaning those out, opening them up and making them match, just so I could use the handlebars. For quality control, it's usually hit or miss. So I got a good set of handlebars here, but the next set might not be good. You might get a great set, you might get some garbage. You really don't know what you're gonna get. And when I say assurance, what I mean there is there's really no guarantee that these parts are well made and safe. So those Bontrager bars I showed you a little bit earlier, Trek has tested those. They've probably done X-ray. I know when I buy those Bontrager bars that I'm going to get a product that's safe. When I buy something like these from China, it's a gamble. And I really don't know if they're going to be safe to use or if I'm going to have any problems with them. So keep those in mind when you're buying carbon parts. It's always a little bit of a gamble. It's always a little bit risky. So that's kind of it for today's video. I hope you got something out of it. Hope you enjoyed it. Until next time, I'll see you guys later.